So let's keep them off the floor by 20 inches or more. You also note directly under this, keep it away from drafts. We just talked about that. High temperatures and high humidities. And the reason that we have these constraints in, that high temperatures and high humidities can have an effect on several of the different detector types. So we want to keep them away from that. And we want to keep it away from outside walls, the reason being that outside walls often have ghost drafts along the surface of the wall. EPA continues to tell the homeowner that the average indoor level is 1.3, and that is probably a reasonable average in the United States. The average outdoor level is 0.4. Now note this, noting that the average outdoor level is 0.4 means that it will be close to impossible to lower the radon concentration in a home to less than 0.4. It could be done, but it would require superhuman efforts to have that happen. Here in this studio at East Stroudsburg University, I have brought a detector, and I'm going to turn this on, and you'll be able to listen to the background. It takes a minute for this to warm up, but I think you can hear the beeping. And in this studio, there is some radiation in the room. And what you're listening to is what we call background radiation. It is, for all intensive purposes, impossible to eliminate background radiation. As we saw in an earlier segment, even the human body is radioactive to some degree. And part of that is being registered by this particular instrument. Now, going back to this visual, we see that if two short-term tests, just look at this statement for a second, if two short-term tests yield an average of 4.1, you have a 50-50 chance that the radon concentration is less than 4. Now, I'm not suggesting to mean that the two short-term measurements had error in them. What I'm pointing out here is that you have a 50-50 chance that the annual average, and you may want to jot that in, the annual average will be less than 4. So if you're making a measurement and it's very close to 4, that is, say, just over 4, 4.1, then you have roughly a 50-50 chance that the annual concentration will still be less than 4. Well, that's what they're told. And I believe that is quite true. Now, what follows on the next page is an array of questions that I would like you to answer just as you have in the past sections. Hopefully you found that you got all the questions right, and if not, you found all the right answers after you tried the questions. One other comment I want to make that is not in the visuals, and I would like you to write this down, perhaps on the page you're looking at right now, and that is that the EPA also points out to the homeowners that they expect that 1 out of every 15 homes will have a radon problem. 1 out of every 15. And you should be familiar with that number for purposes of this exam. Now, the next issue is on what are called false positives and false negatives. This is actually not in the Citizen's Guide, but it's a good place to put this particular topic. And the definition of a false positive, as you see here, deals with a measurement. And if you take a measurement, a false positive indicates, I'm just going to read this, the value determined is on the positive side of the action limit when the actual value is below the action limit. And I give an example. Suppose that you're going to a radon chamber, and the chamber concentration is set to 2. And I'm going to be talking about picocuries per liter here. So the chamber concentration is set to 2. But you go in, you deploy your detector, whatever detector type you're using, you deploy your detector, and you make a measurement, and it comes out to be 5. Now, that's a false positive. It's false because it's on the wrong side of the action limit. That is, the actual value is on the low side. But the value that you found by your detector, for whatever reason, is on the high side of the action limit. It's on the positive side. So it's false because it's on the wrong side of the action limit. It's positive because it's on the high side of the action limit. So it's a false positive. Whereas, if you take a look at what a false negative is, defined and very similarly, a false negative indicates the value determined is on the negative side of the action limit when the actual value is above the action limit. So again, let's go to a radon chamber where we know the concentration is, say, 5, and we put our detector in there, and after the prescribed amount of time we take the detector out, and we find that our detector tells us that the concentration is 3. Again, it's false because we're on the wrong side of the action limit, and it's negative. We're on the low side, whereas the chamber is actually on the high side of the action limit. So that would be a false negative. And let's think about this one now. This one's not in writing, and I just want you to think about it. Suppose that you have a radon chamber, and we set the concentration in the chamber to 2. You deploy your detector in there, and after a prescribed amount of time, you remove it, and your detector tells you that the concentration is 3. To review that, we have a radon chamber set to 2. Your detector tells you the chamber is 3. Is that a false positive or a false negative? And the answer is, it's neither. It's not false because it is on the correct side of the action limit. That is correct in agreement with the actual value in the chamber. It is below 4. It's somewhat inaccurate, but at least it's not a false positive nor a false negative. And there will be questions that follow a little later on that will give you some chance to exercise your understanding of this false positive and false negative. Let's go back to what the EPA recommends now in the Citizen's Guide. And the recommendation is to retest if the living patterns change. Now that makes good sense, and we should bear this in mind, that if you start using your basement, for example, suppose you install a rec room where before you weren't using the basement hardly at all, then you should retest in that space. They further tell the homeowner that in mitigation processes that a reasonably good mitigation system will typically lower radon concentrations to less than 2. And you need to remember all of these things. I'm not delineating any of this material because it seems of completeness, but primarily to review for this exam. And so please make careful note of this information. The EPA continues to give out more information. In particular, it specifies roughly what it has experienced as mitigation costs. And what we see here is that the range of mitigations run between $500 and $2,500 with an average value of $1,200. And they go on to say in the Citizen's Guide that these kinds of costs are typical of the kinds of costs to make other home repairs. For example, if you have an oil furnace and the oil furnace fails and you have to replace it, you're going to spend money in these ranges between $500 and $2,500 to get these kinds of repairs done. So the EPA tells the homeowner that the cost of a mitigation system is very similar to the costs of other kinds of home repairs of this magnitude. They also tell the homeowner to retest periodically every 2 years. Now I think this is a good idea. If you're on a well, typically you test your well every few years to make sure that the condition of the well is still in good condition. And here the recommendation is to retest periodically every 2 years. So if you're familiar with homeowners who have had their houses tested or you've done the house testing, then you might want to generate a reminder file or a tickler file which 2 years from now you'll look at the file and it says, oh yeah, today I should call Tom Jones and remind him. Maybe you could send him a little postcard saying your test was done 2 years ago. EPA recommendation is that you should test again, and this card is to remind you of that. So retest periodically every 2 years is an EPA recommendation. Now, also in the Citizen's Guide, there's a table of health risks for smokers and non-smokers as a function of radon concentration. And there's a lot of data there, and when I first looked at it, I thought to myself, gee, how can anybody remember all this data? But I did find, if you'll bear with me, a relatively easy way to pick out the data, and all you have to do is remember 1 or 2 things. Now, the first thing I want you to note is under non-smokers, right here, you see if the concentration is 2, that the non-smoker has a chance of 1 out of 1,000 for achieving a lung cancer. And what that means is if you live a lifetime in a concentration of 2 picocuries per liter and you're a non-smoker, that the odds of you getting a lung cancer are 1 out of 1,000. Now look further down in this chart. At 4 picocuries per liter, the non-smoker has a risk of 2 out of 1,000. Now what I want you to note here is this. The risk for a non-smoker is half the value of the concentration. If the concentration is 2, non-smoker has a risk of 1 out of 1,000. If it's 4, it's 2 out of 1,000. Now you're going to think I'm misleading you because I'm sure you've all looked at 8 already and seen that that's not 4 out of 1,000, it's 3 out of 1,000. 10 gives you 4 out of 1,000, 20 gives you 8 out of 1,000. But the easy way to remember this, I think, is that the concentration, the health risk rather, is half the concentration, but as you get higher and higher, it's just a little bit less than half. And that will give you a close enough value to be able to answer the questions on the RMP exam. Now it stands to reason that this should be the case, that as the concentration gets higher, the health risk does not get linearly higher as well. That is, it gets higher but it drops off a little bit. The reason being that if the health risk at 2 picocuries per liter is 1 out of 1,000, suppose I make the concentration 2,000 picocuries per liter. Should that make it 1,000 out of 1,000? Exactly 1,000 times the concentration would give you 1,000 times the risk, which would guarantee that everybody gets a lung cancer. And yet we know that humans don't react that way. There are some who still will never get a lung cancer. And so you can't just continue to increase the concentration and say that the health risk increases linearly as well. Although that is typically the supposition we make, it is not exactly correct when we get into the very high concentrations. And that effect you see here. 2 gives you 1, 4 gives you 2, 8 doesn't quite give you 4, it gives you 3. 10 gives you 4, 20 gives you 8. If you went to 200 picocuries per liter, your guess might be, well, it's going to be under 100, and maybe 80, 85 would be right. And so I think you can remember all of these, at least for non-smokers, simply by recognizing that the risk is roughly half the concentration. And as you get to higher concentrations, it's a little less than half. Now that's for non-smokers. Now let's look at smokers. I have a method for this too. For smokers, note the risk is 15 out of 1,000 at 2. That's 15 times the health risk of the non-smoker. Now the reason it's so much more is that when the radon decays, the daughter products are solids, and they tend to adhere to the dust particles in the air, the smoke particles in the air. And if you're a smoker, you're inhaling those smoke particles, they're adhering to your lungs, and so what they're actually doing is they're fastening the radioactivity right to the inside of your lungs. And that increases your lung cancer risk dramatically. So you see the ratio is 15 to 1 at 2 picocuries per liter. And I want you to remember that 15 to 1. For smokers, I would like you to remember that the health risk is going to remain 15 times the risk for non-smokers. Now, let's look at this, and you can see, of course, that this is not exactly correct either, but it's 15 to 1 at 2. Now, if it were 15 to 1 at 4, then this number here should be a 30. Notice it's a little less than that, but not much less. At 8, typically the concentration here of 8 would give you for non-smokers a 4. As I pointed out before, half the concentration. And 15 times 4 would be 60. Notice it's a little less than 60. At 10 picocuries per liter, if the non-smoker were 5, that is half the concentration, but we know it's a little less, but let's take it as 5, then 5 times 15 would be 75, and notice it's a little less than that. And it follows along. So I think the way you can remember this entire chart is to remember that for non-smokers, the health risk is about half of the concentration. And for smokers, it's about 15 times what the non-smoker is, what that health risk is. If you bear that in mind, I think you'll find yourself pretty successful in dealing with the questions on the exam, and that's a pretty good way to remember the, that whole chart to a large degree. You don't remember the numbers precisely correctly, but you get them pretty close. And so the upshot of that chart is this, that non-smoking risks are approximately half the concentration, numerical values, and that's 1 out of 1,000. And that smoking risks are approximately 15 times that of the non-smoker. Now this ends part 3 of the review, and there's a series of questions that follow in after this. So as per the instructions on dealing with the questions, I would like you to now spend some time dealing with the questions that come up on the next page or two, and then return to the video at this part, and we'll begin reviewing part 4. This is part 4 of the review program, and the topic in part 4 is the Consumer's Guide to Radon Reduction. Again, this is one of the articles, one of the pamphlets that the homeowner will receive from the EPA, and it is also covered in the exam. So we need to be familiar with all the details in this particular guide as I've delineated here. As you see on this first visual, the purpose of the guide is to help the homeowner select a qualified contractor, to determine the appropriate mitigation technique, and to determine the maintenance procedures to help maintain the system as the years go past. Again, remember, this is what's going to the homeowner. If you keep this in mind, I think it will help you recognize why these things are being told to the homeowner. And some of the information we've seen in other guides, but here we are. The EPA recommends fixing the home if one long-term measurement or the average of 2 short-term measurements indicates 4 or more. We've seen this in part 3, we've seen this in another part as well, and we will see it one more time again. They're also told that if they're going to buy test kits on their own, the test kit should indicate meets EPA RMP requirements. That's the recommendation. Somewhere on the container of the detector, this statement should be delineated, should be written out. The homeowner is also told to look for contractor references. That is, how do you pick out a contractor? Well, typically you call a few and you get bids or proposals. And along with those, there should be contractor references and photos of previous work. Clearly, if you're the homeowner and you're looking at 2 people and one contractor has references and photos, maybe a photo album of the work that he's done, and the other fellow doesn't have any of that, I think it's a little more persuasive if you have the documentation and letters from other people for whom you've done the work, saying that you've done a good job, etc. So contractor references and photos of previous work should be there, and that's what the homeowner is told to look for. They're also told to expect that the contractor will clearly explain the work to be done. If I don't understand, if a contractor comes to me and I don't understand what he's trying to tell me that he's going to do, I don't think that I'm stupid. I think that that contractor is unable to explain the work that he's going to do. And that, to me, is a negative component of a contractor. So it needs to be clearly explained. They're also told that the contractor is to state if there are any fees or extra fees for diagnostic work. If the contractor is going to do, say, a soil communication test or a smoke test in the basement, etc., are there extra fees for that? Did the contractor inspect the home prior to the estimate? Now, how would you feel if you were the homeowner and you called the contractor and you said, well, the radon concentration in my house on the average is 10. I need to have it mitigated, and the guy over the phone says, okay, $1,500, I'll be there tomorrow and we'll do it. That would not be too persuasive to me. And so the homeowner is being told that they should expect the contractor to come out to the house and inspect the house before making an estimate. And did the contractor review the test results? Now, the contractor, as we will see later on in the review, contractors in some ways will be required to review the test results that led the homeowner to believe that the radon concentration in the house is greater than 4. And so the contractor is going to be expected to review those test results to make sure that the homeowner understands fully that the measurement is in fact greater than 4 if it is. Now, the contractor's proposal, there are 2 other parts to this. Now, one is the contractor is going to make a proposal, and in that proposal a set of things will be delineated, and also then there will be the contract, which will specifically explain those things to be done. In the proposal, it's to include proof of liability insurance. That is, if the contractor or his workers fall down on the job, become injured on the job, whose insurance pays for that? The contractor is expected to have liability insurance. The contractor is expected to have proof of RCP listing. That's the Radon Contractors Proficiency Program that the EPA maintains. And this proof is typically a photo ID card. And again, as you'll see later, if you're going to be in mitigation, you're going to want to be in the RCP program. And so you'll have that photo ID card. In any case, the homeowner is told to look for this. The contract's proposal also should include diagnostic testing. That is, if there's going to be diagnostic testing to be done, if there's going to be sub-slab soil communications tests to be performed, then that should be stated in the proposal. These things will be done. Also in the proposal, there should be the installation of a warning device. The new the new RCP protocols call for a warning device to be put on every mitigation system. Now, typically, the most common mitigation system is the sub-slab depressurization system, and on that, a manometer is usually placed on one of the vent pipes. It's a very simple device, $3 or $4. You can buy them off the shelf through the catalogs now, and that indicates whether or not there is depressurization occurring within the system, as there should be. And so the homeowner is told there should be a warning device. Homeowner is also told that there should be testing after the installation to determine whether or not the system is working. And they're also told that that test, that post-mitigation test, is to occur no earlier than 24 hours after completion of the mitigation and no later than 30 days later. So between 1 day and 30 days, that post-mitigation test should be done. And the homeowner is also told to look and see if a guarantee is part of the proposal. What kinds of guarantees, and for how long will that guarantee be in place? That is, does the contractor guarantee that the mitigation system will keep the concentration below 4 for 1 year, 2 years, 3 years, etc.? Interestingly enough, in the first few years of the radon mitigation issue of 85, 86, 87, guarantees were actually hard to find. But now, typically, in a recent document that I saw, almost 90% of all the mitigators offer guarantees that last between 1 and 3 years. Now, getting into the contract portion, that was the proposal. We look at the contract portion. What should the contract include? Now, think of yourself as the homeowner. What do you want to see in the contract? And I think you can remember most of these things just out of common sense. They should include, well, what's the total cost? Of course I want to know what the total cost is going to be. So that's one item. How long will it take to do the job? Will it take 2 days, 3 days? How long are you going to be in my house doing the work? I would want to know that as a homeowner. That the contract should also include that the mitigator will obtain all the appropriate licenses to do the work, and that all the work will be done in accordance with the appropriate codes that exist at that home. Typically, in this case, I think we're looking mostly at electrical codes. That is, if you're going to put in a separate circuit and a circuit breaker for the radon mitigation fan, for example, that needs to be done in accordance with the codes. So the contract should include these things. It should also include liability insurance, a cleanup guarantee. That is, when the job is over, will the contractor leave the house as clean as when he found it? Will he clean up after himself? That should be in there. The homeowner is told. As a homeowner, I would like that to happen. Details of the warranty. That is, how long do you warranty that this system will operate properly? How long is the fan warranted? The transfer of warranty. Now, this is an important clause. Most mitigation occurs in real estate transactions. And in this case, if I'm the owner and I'm selling it to someone, I'm the one paying for the mitigation system. And so the warranty comes to me directly. But it has to be, for me to have that useful, it has to be transferable to the new owner of the house. And so the homeowners are being told to look for a transfer of warranty that should be transferable. They're also told in the contract that it should specify what are the homeowner responsibilities. Again, if you imagine a sub-slab mitigation system, and you're going to put that one of the vent pipes through part of the slab in the basement, can you get through to that part of the slab, or is there a car parked there, or is a lot of garbage piled up in that corner? is the homeowner's responsibility to give me access to that, or do I have to clean out the garbage to get access to that particular part of the slab so that I can drill the holes I need to drill? So the homeowner responsibilities need to be specified in the contract. Again, we have seen this. The homeowner is advised that the installation costs range from $500 to $2,500. And we've also seen earlier on that the average cost is $1,200. You may want to jot that down to help remind yourself of that. Now, I mentioned earlier that the RCP program, the Radon Contractors Proficiency Program, we're going to be talking about that in a later part of the review, is going to be almost essential for any mitigator to be a successful businessman or business person. The requirements of the RCP program, if you become an RCP mitigator that is listed in the RCP program, there are certain requirements placed on you. And the homeowner is told through this guide what those requirements are. Here we see that labeling must occur. That is, the mitigation system must be labeled. So if you have a clearly labeled, if you must have a subslab system and you have a vent pipe coming from the basement slab up into between the joists of the first floor, then somewhere on that pipe there should be a label, radon mitigation system. Someplace next to the circuit breaker there should be a label, radon mitigation system, so that people will know if that's what that is for. If there's an electrical switch whereby you can shut the fan off, there should be a label there. This switch is for the radon mitigation system. Labeling is required. Also, as part of the RCP requirements, the homeowner is told that the exhaust of the mitigation system must be a minimum of 10 feet above ground level. 10 feet above ground level. That is typically not a problem because most vent pipes go up through the attic, through the roof, or through a garage roof, and are easily more than 10 feet above the ground. For purposes of the exam, though, you need to be aware that it's at least 10 feet above the ground. Now, the reason for this is simple. If you have it just a few inches off the ground, and I have seen mitigation systems where the mitigation pipe lies right along the ground, then someone downwind 5 feet, suppose you have children, and they end up playing in that area, they'll be playing in a radon concentration that is quite high because the concentrations beneath the slab are typically 10, 20, 30 times as much as radon concentrations in homes. And so we want them significantly above the ground so that other people, our own children, for example, do not inhale these high concentrations. Also, don't put them near windows and doors. And of course, the reason for that is to preclude re-entrainment of the gas. That is, we don't want the gas that we're exhausting out of high concentrations of 200 and 300 picocuries per liter being swept back into the house through an open window or a door. So we want them not near windows and doors. The fan location, again, this is primarily for depressurization systems. The fan location is to be in an unlivable area and not in the basement. Now, the reason we want it in an not in a livable area is it's quite likely, or it's quite possible, that the fan or the collars of the fan could break, the fan could become removed from the pipe accidentally in the mitigation system, in which case large concentrations, again, of radon would be deposited right in the vicinity of the fan. And we don't want that concentration getting into the house. So if you put the fan in the basement, of course, and that kind of accident occurs, then that concentration will find itself percolating up into the first floor. So the idea is put the fan in an unlivable area and not in the basement. Oftentimes you'll see them in garages that adjoin the house or in the attic of the house. It's also recommended that the electrical work is done in accordance with the codes. We've already seen that. That only makes sense. You want the electrical work done properly. Also required by the RCP program, a warning device. We spoke about that. A follow-up test. Remember the conditions for the follow-up test. It must occur between 1 day and 30 days after the end of the mitigation system's installation. Now, one extra thing that I've listed here, and this is in the RCP requirements, is that the contractor must recommend that the follow-up measurement be independent. That is, If I'm the contractor, I have to recommend to the homeowner that, first of all, look, the follow-up measurement has to be made between 1 and 30 days, and I recommend to you that it be done by someone other than myself. That way there won't be a conflict of interest, and it will be, you'll be a little more certain that kind of conflict does not potentially arise. Now, in this guide to radon mitigation, the homeowners are also told to watch out for radon in water. And they're told that well owners may wish to test. Again, we've seen that if the radon concentration in the house is 4 or more and you're on a well, the recommendation is to test for radon in the water. And that the ratio, this 10,000 to 1, this ratio is the ratio of the concentration of the radon in water as it becomes radon in air. Radon in water by itself is not a particularly large health hazard. In fact, as long as the radon stays in the water, I haven't seen any documentation indicate that it's a health hazard in any significant way. The problem is that the radon exits the water easily. Any disturbance of the water allows the radon to escape. And that's the problem. If you have 10,000 picocuries per liter of radon in water, and that's not an unusual value, it would be high for radon in air, but it's not an unusual value, then that will induce into a house under typical water use 1 picocurie per liter of radon in air. So if you had 50,000 radon in water, with the typical water uses that radon escapes into the house, that could become as much as 5 picocuries per liter of radon in air. And they're told these are the kinds of values to watch out for. They're also told that mitigation is to be at the point of entry in the house. And that is, if you're on a well, typically the water service comes in through a pipe in the basement, and that entry point, that is where it enters the house, you should expect to put your mitigation system in there. And when we talk about radon in water in another part of this review, you'll see what kinds of mitigation systems are available. But that's where the mitigation system goes, at the point of entry. It is not recommended to use a bunch of little charcoal filters at each faucet. That is not nearly as effective as a mitigation system at the point of entry, not the point of use. Further, in this guide, the homeowner is recommended that there are maintenance needs. And the maintenance needs are as follows. Now, the 2-year checkup test we talked about in Part 3 of this review, and note that that comes up again. Every 2 years, the homeowner is recommended to test their home after it's been mitigated. But the maintenance needs of the mitigation system are to clear debris from the exhaust. Now, you might think that the exhaust pipe is up through the attic of the house, out in the air. What kinds of debris is going to collect on that? Well, there's the potential for birds' nests, squirrels' nests, all the kinds of problems you can have with a chimney, you can have with the exhaust pipe of a mitigation system. If there are filters, the filters are to be cleaned periodically or replaced, depending on what kind of filters are being used. And to periodically check the warning indicator. When we say to check the warning indicator, that means that the warning indicator should be easily seen. It should not be in some place hidden where I have to struggle to go see it. The mitigation pipe, if it's not in a wall, will be out in the room somewhere. And it makes sense to not put the warning indicator on the back side of the pipe where I have to lean over to get to see it. Put the warning indicator on the front where it's easy to see, and so the homeowner can easily check it. What follows, again, is a list of questions, and I'd like you to deal with those questions as you've done in the earlier parts of this review, and then return to the tape at this point.